everyone. Welcome to the cybersecurity section. I hope everyone is doing well, first of all. And in this COVID section, I hope you and your family members, everyone is doing well. Okay. So to give some brief about the section, though we know that cybersecurity is the practice of protecting network system, hardware, and data from digital attacks. And also, we have cyber threats are common actually in globally, and also from enterprise level to the end to end, for every user, everyone can be a victim of cyber threats. So we are here to know much more about the cyber security area. We have very good experts here, so we can get started with the Olaf, the first speaker. So let me introduce our first speaker. Our first speaker will be our Olaf Kolkman. So he's the present principal internet technology policy and advocacy of the Internet Society. Uh, Also, Wolf is a senior advisor and spokesperson of the Internet Society. He formulates reviews and advice on technical and policy positions. Wolf has a long experience in technology and policy matters, in particular those related to security and trustworthiness of the internet. He is a board member of the Global Forum and on expertise in cyberspace, and a commissioner of Global Commission on the Stability of Cyberspace. So we'll go on listening to the Olaf, the very good section, and we'll take advantage of it. Over to you, Olaf.
Thank you. I'm very happy to be here. It's a joint session organized by the Rural SIG and our cyber security SIG, special interest groups. Let me just plug a little bit for the people on the live stream who are not aware of the special interest groups. You can join those just by signing up to them. You can find information via the Internet Society website. Look at the chapters page, how to get involved. And you can join a chapter or a special interest group fairly easily. So if you have any special attention or interest in the topics of cybersecurity or rural internet, then sign up to the SIGs. And a shout out, by the way, to Jolly, who is always streaming these things and makes this material available. Thank you, Jolly. Let me share my screen. So I'm going to talk a little bit about cybersecurity. I hope you can all see my my video, my screen here. Let me talk a little bit about the Internet Society. Our goal is to have an open, globally connected, secure, and trustworthy Internet for everyone. And all these words matter. All these words inform our daily job at the Internet Society. We want an open Internet, an Internet to which you can connect, to which you can extend, which you can communicate on in an open fashion. We want to have it globally connected so that everybody can speak to everybody else who actually wants to talk to you. We want to have it secure, and we want to have it trustworthy. And trustworthy is not that it instills trust, but it is actually worthy of instilling trust. So it's technically solid. And we want an internet for everyone. Secure and trustworthy are the words that are relevant to the cybersecurity special interest group. And an internet for everyone is, I would think, more of interest for the rural security interest group. Special interest group. The word security is on my mind a lot lately. So when I was thinking about these two topics, then the first thing that came up with cybersecurity is always, what does this mean? And for me, cybersecurity is broadly divisible in two parts. This is my own sort of way of thinking about it. To me, cyber is the combination of two things: the ability to digitize our physical world around us and perform computation on that digital information. That started way back when IBM started to digitize business information, ledgers of all sorts, and started to compute financial and bookkeeping type of things and automated that. That went to office automation, text sharing, and all those type of things. And now we digitize videos, we digitize all sorts of information to compute on it. And computation could be just algorithms. It can be artificial intelligence type of algorithms. It can be anything. That's one part of cyber. The other part of cyber to me is the internet, the network of networks that allow you to share the digitized information across the world. So you create a video, you shoot a video somewhere where you capture analog signal, you digitize that, and you can share it across the world. You can store it, you can process it anywhere else on the world, and that is what the internet allows you to do. For me, the internet is that platform of connectivity that provides you the ability to do computation, to build services, to do all these type of things in the cyber world. So when I talk about cybersecurity, there are two aspects. There's the cybersecurity of those digital transformations and calculations, and there's the cybersecurity of the internet. And as I work from the Internet Society, I will be mostly focusing on that second part. Now, when I was thinking about the rural special interest groups, so places, non-urbanized places where internet is brought, I was really thinking about what are the differences between cybersecurity elsewhere and cybersecurity in the rural place. What are the differences? And frankly, I found it very hard to come up with differences in cybersecurity approaches in rural areas and cybersecurity elsewhere. I think there is a little bit of a difference. I will get back to that at the last at my last slide, more as a thought, as a theory than as a bold statement. By the way, I don't think there are 10 differences in these two pictures, so stop counting. When we talk about cybersecurity in the Internet Society, mostly we approach that by a framework which we call collaborative security. And collaborative security is the idea that security is not a state, but a process. It is a frame of mind whereby it is important, and this is specifically important for the internet, that you're not the only actor. You're not only protecting your assets, you are protecting an asset that is globally shared and in which many parties have a responsibility and their own responsibility in managing the pieces that they are responsible for. Remember that the internet itself, the network of networks itself, is a network of 60,000 networks. And all those networks connect homes, connect villages, connect enterprises, connect things, and all those type of things need to be secured as well. This is where you sort of hop along between securing the internet itself, but also everything that connects to the internet. And there are a few principles that we keep in mind when we talk about global internet security, about collaborative security. First is the principle that you need to foster confidence and protect all the opportunities that the internet brings. The internet brings a lot of opportunities. We know there are problems with the internet, problems that are often in the news, breaches of trust, breaches of expectations, and we absolutely need to fix the problems that we see. But by doing so, we have to make sure that we don't break the fabric of the internet itself and the things that make the internet possible. The open nature of the internet, the ability to innovate, the ability to globally connect, all those things are bringing opportunities that you want to protect. And that protection is actually a collective responsibility. Everybody has to play its part. And when you do that, you have to take into account fundamental properties and values, values of a universal nature, like the Universal Treaty of Human Rights, but also the fundamental values and properties of the internet itself, permissionless innovation, openness, those type of things. When you create solutions, then create them by evolution and consensus. Revolution and imposing solutions is sort of the other extreme, and is not guaranteed to lead to success. It's better to do tests and reject what doesn't work, and have a form of consensus about what you deploy in the internet. And then finally, and this is an important one, think globally but act locally. Everybody can play their part in securing the internet, and you do that locally, but you have to take into account the global nature of the internet when you do so. That is both when you protect your own assets. There's a world of ill-intended people out there that are coming to get you, so to speak. But also, there might be somebody in your network or in your environment, or you might have coincidentally downloaded a virus or something, or a piece of malware that is exploiting somebody else on the internet. So think globally, but act locally. Take your responsibility. So that's the framework. And the way that this is implemented, this is just a graphic that I hope illustrates that. People often ask us, what are people actually doing to implement all these type of things? And if you look at all the organizations that take their responsibility and how consensus and coordination is established, then there are a lot of these groups. There are the CSIRT, the security incident response teams, in nations, in corporations, which collaborate and so on and so forth. There are law enforcements, there are ISP groups, there's a lot of different groups that all collaborate together to take their piece in the global picture of cybersecurity. And I'm not going to explain this picture because that would take me more than 15 minutes, and I only have 15 minutes left. What I wanted to do now is a little bit of an overview of the cybersecurity-related activities in our programs, in the activity program for 2020, and likely also for the programs for 2021. We're likely to continue these. And those are routing security, encryption, time security, and policies that favor a secure and trustworthy internet. Now, I'm not going to talk about these policies that favor a secure and trustworthy internet because they are probably a presentation by themselves. What I do want to talk about or touch upon a little bit are time, encryption, and routing security. And here I'm trying to think a little bit also on the rural perspectives on these type of things. Is there a rural component that makes these projects special? And frankly, I think the answer, and I'm going to spoil it a little bit, is going to be no. Let me start with time security. Time security is one of the projects, it's one of our smaller projects at the Internet Society, where we are interested in making sure that the network time protocol, the protocol that distributes time on the internet, becomes secure, and that security is also deployed. Why is this important? I won't spend much time on this, but it is important because every security transaction on the internet relies on time. Every single one of them. If your clock is off, you cannot validate signatures. If your clock is off, you might be heading to the wrong website that has an expired certificate. If your clock is off, DNSSEC won't work. If your clock is off, and I can continue and I can continue. Now, clocks are somewhat of an attack vector, and making sure you have correct time is therefore very important. There are two aspects to that. Maintaining a well-run clock is very important, but also making sure that the distribution mechanism of time itself, the network time protocol, cannot be spoofed, attacked, or whatever. And that's currently, frankly, that's currently possible. So our work in this area is in the very early stages around standardization and making sure that there are bringing together people who work on early implementations and seeing to it that there is progress made, hopefully towards more professional and over the counter type of products that will support time security. This is obviously important for everybody on the internet, except that the people who are involved with this now are specialists, are people that are interested in time distribution. And this is not, say, for your regular consumer. So I'm going to continue to the next part. And that's routing security. Routing security is already a little bit more important. Routing security is important because whenever you have traffic that transfers the internet, it's being routed from spot A to spot B. Here is a picture of the internet, a very sketchy picture of the internet, where every little cloud here represents a independently owned and operated network. And there, on the current internet, there are about 60,000 of them. And whenever these networks say, you can reach my customers here, they will say that to their neighbors will say that to their neighbors, and those will say that to their neighbors. So internet routing is actually a whispering game. And the security of a whispering game is abysmal. One of the ways that people try to secure this is by having the best practices that we know on how to operate this, making sure that those are at least implemented by all these participants. That's why we have the mutually agreed norms on routing security program. Now, I won't talk a lot about routing security because that will be the next speaker. But remember, routing is a whispering game, and whispering games are inherently insecure. Now, what does this mean for the rural people, so to speak, people who are not, you know, at the center of the internet, so to speak? I think there are no special considerations. If I look at rural internet, it's most likely that you're connected to an edge network, and that edge network has their own responsibilities for routing, but you as a connectee do not have specific responsibilities there. It is your internet service provider that has. Third part, encryption. Encryption, I think, is important for everybody because encryption is a little bit more about the interaction between the digitized world and the internet itself. It is about getting information from A to B and making sure that it is done in a secure way, that the data is protected from change, but also that the data that is transferred is not readable by others. This is important in many, many, many daily interactions. This is important when you do your banking business. This is important when your kids are sharing location data because they want to walk home safely. This is important when your medical records are being stored. This is important when you vote. This encryption is important in all aspects of daily life. And again, I don't see many differences specifically with the importance of encryption between rural and urban communities. So this is also important for everybody else. At the Internet Society, we care a great deal about encryption because it's under attack, so to speak. There are agencies, law enforcement agencies, that would want to disable encryption or make it much weaker. We don't agree with that. The Internet Society believes that encryption should be the norm for internet traffic and data storage, because that will make the internet a more secure place. It will make it more private for the individuals that do their business and do their daily lives. And it will allow us to communicate trustworthy. Encryption is a technology that is inherently trustworthy. You can rely on the functionality of that technology. Strong encryption ensures that law enforcement communication, civil authorities' ability to communicate with each other, and banking transactions are all protected. Legal and technical attempts to limit the use of encryption, even well-intentioned, will negatively impact the security and law-abiding citizens and the internet at large. This is the Internet Society's position on encryption. And this, I believe, again, is a topic, as I just said, that is relevant to all users of the internet. Which brings me to a question for the last 3 minutes of the presentation. I've been thinking a lot, what is the difference if it comes to security between rural and urban areas? What is the difference in cybersecurity? Well, I said a lot, but I've been thinking a little bit about that. I shouldn't exaggerate in that. I think that for rural communities, the issues are really with capacity. It's not only the ability to connect people, which we know in rural areas is sometimes much harder than in urban areas, in urbanized places. Obviously, the Internet Society is interested in making sure that people get connected. We have large programs around that, like building community networks and enabling the possibility to build these. But this is more capacity on the human front. Where do you find the specialists that can help you with protecting your internet, the internet in your school, or the internet for your business? If you're a small business, a small farming business, for instance, and you want to make sure that the price of crops get to you, and you can communicate in a safe way what your business secrets are, or what your yield, for instance, to make sure that your business runs well. And those specialized functions are often easier to get in urban areas. That's where the people who do cybersecurity have their offices. probably not that easy in the rural areas. That's a thesis. I do not know if that is true, but I would like to um, uh, I'd like to test that with the group. It's clear that access is critical to the rural economy. That's at least clear to me. Anywhere where the internet comes, you have more information about prices, you have more information about the rest of the economy, and ICTs can play a role in that. And having global connectivity can help in that aspect as well. And so my question would be, what can the internet, how does a connectivity help you to get to the ICT capacities that are needed to secure your networks and help secure your environment? I think that is a slightly different set of considerations than for non-rural environments. But again, that's a thought, and I would like to hear your thoughts on that. And with that, I think I'm done. If you have any questions, you can reach me at the email address on this slide. And I also have a Twitter account at Kolkman. That might also be a way to reach me. Thank you very much.
Thank you so much for the nice presentation and addressing us about the policy, about the rural perspective of an issues, and also about the routing stuff. So, and also much on encryption as well. So thank you. It's been very wonderful knowledge base for us. So I request the audience to drop an email if you have any queries. Feel free to reach us anytime. So even Olaf have shared his email and Twitter ID as well. Please make use of it to ask questions. So we have one question here. Can we take up a question now just for 2 minutes, Dr. Olaf?
Yeah, of course.
So there is a question from Mr. Pradeep Gupta. So what should be the role of civil society in cybersecurity related issues?
Well, the role of civil society in cybersecurity issues is large. Specifically, if you get to the cybersecurity issues that are a little bit more towards the application layer. Time security, I'm not so sure whether there is a big civil society role there. Routing security, also not that big. Although civil society has been rather supportive of, for instance, supporting a norm that is currently being discussed in the UN that has to do with the protection of the internet infrastructure. For those who don't know, there's this process in the UN where they are discussing international stability law norms. How do states approach each other in time of cyber warfare and cyber peace? And one of the norms that people are discussing currently in a group called the Open-Ended Working Group is the norm to protect the public core. That routing security is part of that, I would pose. And that is already a place where many stakeholders, including the civil society, take conversation. With respect to encryption, the input of civil society is, I think, critical. This is where we're talking about, we're not only talking about technical issues. Encryption is a technical topic. Encryption is a technical activity, but the way you use encryption, the impact that it has if encryption is not available to personal safety, to the way you can communicate, is a topic that is clearly also within the realm of the civil society. So that was a long form of a short answer, and that short answer is civil. As with any topic that relates to the internet, civil society has a role in the discussions, just as much as the technical community has, just as much as um, governments have in all of their respective roles and responsibilities. I hope that answers your question.
Yes. So thank you so much. If anyone have more queries, those who are watching the live stream, please feel free to drop an email for us to the Rural Development SIG or else to the Cyber Security SIG. We will work helping you to clarify your queries. And also you can reach us to Dr. Olaf as well. Thank you so much, Dr. Olaf, for your precious time, and it's pleasure to hear from you. So it's time for us to go with the next speaker. Our next speaker is Dr. Kotikalapudi Sriram. So to tell, let me introduce about Sriram. The Sriram is a senior research engineer in the Advanced Networking Technologies Division at the National Institute of Standards and Technology, that is NIST. So to tell more about Sriram, Sriram is currently working on NIST. So he also held various positions at Bell Laboratories. So the innovations of ARM and Alcacelsen Technologies, and also formerly that of Lucent Technologies, AT&T. And he titles at Bell Laboratory included consulting member of technical staff, and he also published over 60 papers in various IEEE and other international journals and major conferences as well. Okay, so Sriram is today going to present us about practical solutions for internet routing security and DDoS mitigation. I'm very curious about to hear it. So over to you, Sriram, please.
Thank you, Adarsh. Good morning, good afternoon, good evening to everyone, depending on where you are. So I'm going to talk about more details. Olaf already gave a nice brief introduction to routing and some key routing security issues. I'm going to delve deeper into that. The routing security, as Olaf already mentioned, is something that that will be taken care of by the edge networks, the transit providers of the edge networks, and then up the hierarchy. So let me share my screen. One moment. Can everyone see my slides?
Yes, we are able to see your slides.
Great. So today I'm going to talk about practical solutions for internet routing, security, and DDoS mitigation. The focus of the talk will be Border Gateway Protocol, or BGP routers, prefix, and the vulnerabilities there include prefix hijacks, misrouting, route leaks. We'll also briefly talk about distributed denial of service, which is done by flooding servers with IP packets, and these IP packets often have spoofed IP addresses. And also in that process, open internet servers such as the DNS are used, they are exploited to amplify the DDoS attacks. And we'll look at some standards-based security solutions. So there has been a lot of good effort that has been devoted towards BGP security and best common practice guidance. I mentioned here a NIST document and also the manners, mutually agreed norms for routing security that Olaf has already mentioned briefly. Of course, I have not shown IETF here and several other organizations, but many organizations around the world in the public sector, in the private sector, are very actively working on routing security. And we ourselves, several of us at NIST, myself, my colleagues, have been very actively participating in the IETF. And the NIST 801, NIST Special Publication 800-189 document that I'm showing on the left side, it covers the topic of BGP security and DDoS mitigation. It provides security technologies for these two areas, gives a nice overview of those overview of those technologies, and also provides security recommendations. And Manner's effort is very complementary to the NIST guidance. Manner's includes several implementation guidance documents, and those are highly complementary to the SP 800-189 document. The 800-189 document contains two main topics, as I said: control plane or BGP security, and also it covers DDoS mitigation, reflection amplification, vulnerabilities, and solutions and recommendations for those. And as you can see, we cover a variety of topics subtopics under each of these, starting from registration of route objects in the Internet routing registries, certification of resources in the RPKI or Resource Public Key Infrastructure, BGP origin validation, and so on. There is also route leaks, which I will talk about briefly later. And on the right-hand side for DDoS, source address validation is key. And there were some constraints, some limitations of BCP 38, BCP 84, because of which source address validation did not get adopted widely. Many networks do it, but we would like to see much broader adoption of those in order to mitigate DDoS attacks. So we also provide solutions that are available in standards, including some new standards, which I'll talk about later, that mitigate DDoS attacks with source address validation. And we also provide information about, in the document, we also discuss employing traffic filtering at open internet servers at the TCP and having monitoring of TCP UDP ports. And we talk about BGP's flow spec as well as RTBH, remotely triggered black hole filtering. So jump in quickly about the vulnerabilities associated with interdomain routing. Excuse me. So if you look at this picture on the left-hand side, there is a legitimate announcement 192.0.2.0/24, and the same prefix is hijacked and announced on the right-hand side from AS 64510. And that is a hijack. And what happens is that in the absence of routing security, in the absence of BGP security, this attack, the BGP attack update, will propagate across half of the globe, half of the internet, and users will be misdirected to the attacker. So the result of these attacks is denial of service, misrouting of traffic, and resulting possibility of eavesdropping on the information, and unauthorized routing. There have been many threats that have made headlines in the newspapers and trade magazines. These threats or the motivations behind those attacks could be financial, or they could be, for example, there could be other motivations. And in the case of Iran route leaks or BGP attack, the motivation was censorship in the country. I want to show this slide, an example, a real attack that happened in 2018, and it illustrates to you the vulnerability in some more depth, and then you'd be able to appreciate why the security solutions are so important. So on the left side, we have the Amazon authoritative DNS, and on the upper right-hand side, an imposter Amazon DNS is operating, and it is using a compromised router in the Columbus, Ohio location. And in this attack, the attackers made a use of BGP hijacking as well as like an imposter DNS hijacking. So the imposter, what happens is that the imposter Amazon DNS is essentially operable because the hijack propagated across the internet. And hijack is a more specific prefix. It propagates everywhere in the internet, unless there is routing security. The users are reaching the imposter DNS as a result, and then that DNS misdirects the users to imposter myethernetwallet.com server in Russia. And the unsuspecting users will put in their credentials there, and the imposter or the attacker is then able to go to myethernetwallet.com on the upper left side and be able to accomplish the stealing of the cryptocurrency. So you can see the vulnerability of BGP are enormous, and there are global implications of it. So there is work in the IETF that has happened over the last 10 years or so that covers BGP origin validation. It covers BGP path validation or BGP set. It covers BGP route leaks, amongst other topics. And today we are going to look at in a more detailed way about BGP origin validation, and also we look at route leaks briefly. So there is the whole RPKI infrastructure. This shows the hierarchy of the internet resource allocations. It starts off at the top with IANA and the 5 different RIRs in yellow. And these RIRs allocate resources to ISPs and to enterprises. The dotted line is simply IANA allocation, but the solid arrows correspond to the resource certification hierarchy. So ARIN, RIPE, those are the 5 trust anchors, and they allocate resources to ISPs, enterprises, and ISPs in turn can allocate resources to their subordinate ISPs as well as customers. So these are resource certificates. This is a hierarchy of resource certification in the next slide. So once the customer, for example, or an enterprise has a certificate for their resources, the prefix, the AS number, they are able to then create a route origin authorization. And with a resource certificate corresponding to their prefix, they can sign the ROA. The ROA contains multiple prefixes potentially that the customer wishes to originate, and they can specify the AS number from which they originate. They also specify max length, meaning that the BGP announcement, the prefix should not exceed the max length. So the ROA essentially is something that the routers in the internet, the border gateway protocol routers would make use of the ROAs to implement routing security. This is again about how this whole infrastructure works that I will describe briefly in the next few slides. We have this RIR hosted RPKI infrastructure on the left, and the user or enterprise on the right, a point of contact for the enterprise. They have resources, prefixes, AS numbers, and they connect to the RIR through a hosted service portal. And they are able to authenticate themselves, and then they are allocated resource certificates, private key, public key, which are hosted within the RIR. And the user is then able to use the resource certificate, the private key, to sign their ROA and put it in the repository. Now, on the next slide, once again, the hosted RPKI infrastructure here. Once the user's ROAs and the resource certificates are created, they are stored in the RPKI publication point. From there, the relying party of RPKI will download the RPKI information, such as the resource certificates, which include the public key that is needed, as well as the ROAs. And once this information is saved in RPKI caches, from there it can be utilized within the autonomous system of the enterprise or the ISP to make their BGP routers secure. So from the RIR repositories, the RPKI is downloaded into RPKI caches, and from the RPKI caches, the ROAs are processed, and the X.509 authentication is performed, validation is performed, and then what is called a VRP, validated ROA payload. Those are created, and the validated ROA payload is then fed into the routers, either through the RPKI router protocol or a network management system. Now the routers are ready with a whitelist of what prefix origins are valid and what would be invalid, and based on that, they can perform their routing security or origin validation. And this is an additional detail which talks about delegated the RPKI. I will skip over that in the interest of time. The resource certification status is that all 5 RIRs have production RPKI services. Then BGP routing, BGP origin validation details. So once you have the enterprise AS or the ISP autonomous system, you have the border gateway routers, the BGP routers performing origin validation on the left and the right in the figure. The validation is performed on internal BGP announcements in iBGP, as well as external BGP announcements that come in over eBGP. And these announcements are the prefix origin pair from these announcements is compared against the VRP. And the VRP with results, it gives you 3 different outcomes: not found, valid, or invalid. Not found means that the resource owner, the prefix owner, has not registered a ROA, and therefore we cannot tell whether this is actually valid or not valid. When the resource owner has registered a ROA, then the prefix origin in the update or the VRP and the VRP are compared. And if there is a VRP that matches the route prefix, it would be valid. And if at least one VRP covers the route prefix, but no VRP matches the announcement or the route prefix, then it is declared invalid. So there are 3 states. Then based on that, you can have local policy decisions, whether to drop the invalid updates or prefer depref the invalid updates, etc. But one has to be careful about choosing which policy, because not all of them provide the effective solution that is tailored to your need. You may just choose to monitor, or you may choose to drop the invalids. One has to carefully think about that and factor it into their policy. Then there are, this slide covers the BGP operational status, gives you a number of references to look up regarding core specifications in the IETF, commercial implementations of products, services, production services, pilot and operational deployments, RPKI. Then on the right-hand side, there is additional information about workshops, documentations that are quite relevant. We now delve into measurements related to the origin validation. Here we talk about source certification measurement, resource certification measurement. In other words, like you have the RPKI infrastructure, the internet service providers, the enterprises have created their ROAS. What we are doing, we have a monitor at NIST, and what we do every day is look at download the data from the RIR resource registries and so on, and we take so the RPKI data from there, the ROAS, and looking at those ROAS, we also look at the BGP announcements from route views and RIPE RIS, and we match the two against each other. So we determine what announcements in the route views, seen in the route views or RIPE RIS would be valid, invalid, or not found, and we report on the statistics. On the left, you see that 20% of the prefixes in the internet globally today would be valid, and that number should grow substantially over the next few years because of the substantial efforts that are taking place across the networking community. On the right-hand side, the focus is on RIPE only. And here we are not looking at the prefixes, but instead the address space in /24 units. Here we see that the valid is a nice 47% figure. And this is not as good for other RIRs. RIPE is ahead of the other RIRs. The next slide it shows you who are the early adopters. So we look at autonomous systems, the prefixes from them, whether they are valid or invalid. And this reports a ranking of the ASS in terms of the validation, the maximum number of maximum amount of address space that would be valid for any given AS. And this is the ranking of top 25 ASs. We do a pretty detailed analysis, delving into the current invalid routes. First, we identify what is the cause of the invalid. Is the AS number is incorrect, or if the max length is exceeded. Then we delve even deeper. We ask the question, if I have an invalid route and if I drop it, where will this traffic go? Instead of the invalid route, the traffic would go to another valid route potentially, or maybe another not found route. And those routes may be the same prefix or they may be less specific. In either case, the traffic is going to a legitimate prefix, potentially a legitimate prefix. Then we delve even deeper and we ask, is it going to the same origin AS or a different origin AS? Does it have the same AS path to the originating AS or a different one? So those questions are also answered. So we have a monitor that is currently existing, and then we have a new monitor which we call Monitor 2.0 that is not online yet, but that provides these kinds of additional detailed information, and also it provides detailed information about day-to-day changes in the RPKIs, in the ROAS, etc. So there are efforts that monitor the adoption of RPKI, and this provides this website, rpki.net, shows you which ASs are currently doing validation. So there are about 117 ASs that I looked up a couple of days back, and of those, most are using ROV at the Amsterdam Internet Exchange route server. Then there are BGP implementations. In the interest of time, I'll just point you to the references here, both RPKI infrastructure-related implementations on the left and the router implementations on the right. Please follow the links and you can get a number of details. Again, on this slide, in the interest of time, I'll be quick. There are innovative tools and techniques that are being made available by Amsterdam Internet Exchange. Once again, their implementations. Cloudflare is also very actively involved in propagating promoting and increasing the adoption of RPKI in multiple ways. There are a number of efforts in the IETF. I'll not go into the details that are listed on the right-hand side. Let me talk next few minutes about route leaks and DDoS mitigation, and then we'll conclude and go to Q&A. Route leaks. So this is also a very significant issue in the internet with BGP. Thousands and thousands of route leaks happen every day. Some of them make it to the newspapers, but many of them don't, because when the route leak is still carrying the traffic to the appropriate or legitimate destination, then people don't notice them. But many route leaks happen that people do notice, and they cause major disruptions. What is a route leak? If you look at the AS1 on the left, it is an internet service provider, transit provider. It is sending a prefix to the customer. The customer should send it only downward to their customer, but not up towards another transit provider. So that would be so internet routes are supposed to be valley free. But in this case, you'd see that it is not valley free. The customer is propagating it back up to another transit provider. That's a route leak. The transit provider ISP2 does not detect, and they propagate it further, which makes things really bad. So these things happen every so often and cause major disruption. In principle, when your BGP router in your network as an enterprise or ISP receives a prefix, it should propagate it to, when it receives the update from a transit provider or a peer, it should propagate that update to customers only, but not to another peer or transit provider. And that basic principle is violated in route leaks. There are several efforts in the IETF which are listed here. I'm involved in those. So there is a RFC on definition, and there are also drafts that cover route leaks solutions. So without going into too much detail, let me just briefly describe what a route leak solution looks like in this slide. Essentially, DO means a down-only indication. It could be an attribute, or it could be a community in the BGP update. The customer sends their prefix upward from AS15 to AS5. AS5 is sending it to a lateral peer. It says down only, and it says I'm AS number 5. I put in down only. From this point onwards, it should go only down. But down the stream, if AS6 leaks it to AS2 with the down only indicator attribute or community, in the BGP update, AS2 is able to detect it's a route leak, and then they can stop it. Very quickly, next 1 minute, and then 1 or 2 minutes, and then I'll talk about DDoS, IP spoofing and reflection amplification. And that will be the last topic for today, for my talk. The DDoS attack happens when many botnets, laptops, desktops, tablets are compromised on the lower left, and they become botnet sources. And they can be used to generate DDoS traffic towards a victim on the upper right-hand side. But along the path, these messages could be directed with a spoofed IP address. They can be directed to an open reflector such as DNS, and then that responses from the DNS or the open internet server would be directed to the victim, and the victim will get amplified a huge volume of attack traffic. And it can also be, this attack can also be performed from the cloud upper left-hand side. So the solution is source address validation and unicast reverse path filtering, which have been around for a long time, but the adoption is not great. And that is because of some practical limitations. And without going into details here, the practical limitation, basically what you are doing is that if you have a peer, BGP peer, and you get BGP updates from them, Then when you get a data packet, you look at the source address and you say that, did I get a prefix update, BGP update from this peer, this neighbor, which contains this source address? If not, you drop the packet. So that is strict URPF. And there is loose URPF where you say, okay, not just this neighbor, but do I have a route in my routing database, which covers the source address in this data packet. If there is such a prefix which covers the source address, that would be loose URPF. And feasible path cares about, so strict cares about directionality a lot. Loose does not care about directionality, but feasible path is the middle ground. And what we have done is we have advanced the feasible path URPF, and we have something called enhanced feasible path URPF. It's an RFC 8704, where it is described. So just in one last slide, I would like to share with you what the enhanced feasible path algorithm does for you, URPF does for you. Let me go to the picture. So essentially at AS4, you are doing source address validation, and you want to minimize the false alarm, the false dropping of legitimate data packets. That has been the main concern with the URPF and source address validation. And this enhanced feasible path improves the URPF a great deal in terms of minimizing the false alarms, and at the same time being able to drop invalid data packets that have spoofed IP addresses. The key principle here is that the AS4, the border routers in the AS4, they look at what are the updates I'm getting, which have AS1 in common, for example, and it is getting 3 prefixes, P1, P2, P3 from 3 different directions, from customers, from peer. And it says, okay, I have P1, P2, P3, which all originate from the same AS1. So I'm happy to give the benefit of doubt. These data packets can now come with address in any of these prefixes from any of those 3 interfaces. So that way it adds flexibility, it compromises directionality a little bit, but it gets pretty more accurate in terms of reducing the false alarms. So that's the key concept. So with that, let me point you to a NIST project website. And now I'm open to, thank you very much for listening, open to questions.
Thank you so much, Dr. Sriram. So
Okay,
please, if anyone have any queries, you can drop us a message here. And also I got a query, is this slides can be shareable? With Dr. Sriram permission, I hope we can share the slides, right, sir?
Yes, I have already given you a PDF, and absolutely fine. Please share them.
Yeah, sure. So these slides will be, we will email to everyone, or those who attended the section, sure, because they're asking so many links there, useful. Okay, sure. So we have a question here from Dr. Shobha Kehar. So the question is, what are the other attacks that are possible on BGP?
So we talked about BGP hijacks. We talked about route leaks. There is also the DDoS attacks are also partly related to BGP, and it's BGP-based techniques that can stop DDoS attacks with spoof addresses. So those are three major ones. Now you can have, even if you have, so we've already proposed that you are going to use or the internet service providers, enterprises, ASS are going to use the route origin validation, RTI and route origin validation, in order to mitigate BGP hijacks. But let me share with you another attack that can still happen even if you have route origin validation. And that would be the attacker cleverly, what they can do is that they can take the autonomous system of number of the from the ROA, the legitimate AS that can announce a prefix, and it basically uses that as the first AS in their BGP announcement. So basically they are spoofing. It is they are falsely inserting wrong origin AS in their update, even though I mean, there is a ROA for it, and just want to be able to beat the origin validation mechanism. What happens now is that when that update is received by the routers, naturally they think that the prefix is being originated from a legitimate AS, and it gets accepted. So that is one type of attack that can still happen. And extending that, you can also say that now you get into the BGP path, the path. The AS path can be modified. What we already said, the spoofed origin attack is a form of AS path. So now we get into the question that the whole area of like AS path protection. People can shorten the AS path in order to make the routes through their AS preferable, or they can, by doing that, they can redirect the traffic through their AS and do eavesdropping on it. So those kinds of things happen. So shortening the AS path length, forging the origin AS or spoofing the origin AS like I described. What is the solution for that? You have to provide a protection for the AS path. So for that, there is the BGP SEC solution, which is RFC 8205 and related ones. And that secures the BGP path, but that is a significant effort in terms of like doing cryptography throughout the BGP system. So let me stop there and see if that satisfies the question.
Yeah, thank you for that. So we have one more question from our live stream channel. The question is from Shweta P. So the question is, could you tell me much more how AS2 is able to detect the root leak that you presented in the slide number 29?
Sure. I'm still sharing the screen, I think. Let me see.
You have to reshare the screen.
Yeah. I don't see the PDF that I was using. Let me see what happened. Oh, okay. So you can see the screen now, I think.
Yes, we are able to.
So in this picture, that's what Shweta is talking about, I think. So essentially, every time, so in this example, the BGP update starts from AS15 on the left side from a customer, and it goes up on a customer provider link to AS5. AS5 shares it with its peer, which is AS1. And when it does that, it inserts the route leak protection attribute, which is down only. It says down only, and it provides also its own AS number so that other ASs know who put the down only. AS1 also does that. AS1 sending it to its customer, and that also says down only. And it adds its own down only equal to 1. So now there are two down only communities in the BGP update. When AS6, that's a customer AS, and it leaks it to another service provider. It is multi-homed. It receives the updates and propagates it to AS2. And I think your question is, how does AS2 know it is a leak? So AS2 receives actually the same prefix route from two different ways. It receives it from AS1 on a P2P link, most likely. It also receives it, the bad one, the leak, from AS6. Now AS6 looks at the update from AS2 looks at the update from AS6, and it says, oh, it has down only indications, meaning that AS6 is leaking it. And that is how AS2 detects it, and then it can drop that update. That does not mean that it loses connectivity to that prefix, because the same prefix, another route is available on that P2P link between AS1 and AS2, or it may be available in multiple other ways. So AS2 still has connectivity to the prefix. It is just rejecting the route leak. Yeah, that answers the question, hopefully.
Thank you for that. So we have one more question from Dr. Sudha Bhuneshwar. So the question is, what could be the other potential research areas available on this topic?
Certainly, there are many. So if you, one possibility is as a graduate student yourself, or if you are a professor, your students, or if you are a researcher, you can delve deeper into RPKI, and there are issues concerning the operations of the RPKI, and also how RPKI can be enhanced with additional what we call like similar to the ROAS, route origin authorization. It is an example of an authorization which concerns the BGP origin and the prefix. And you can extend that to other things, and there are such efforts happening in the IETF, and that look at a different way of path protection, a different way of route leak mitigation. And those efforts are happening in the IETF. Some of those references are in my slides, as well as in the 800-189 document. So definitely looking at RPKI in greater details, contributing to the operational aspects, adoption aspects, any new directions that you can do with RPKI, adding more authorization objects into the RPKI system, the repositories, IETF effort related to ASPA, which Alexander does in Russia. He's an active participant in the IETF and a co-author with me. So those kinds of efforts you can look at. BGP-SEC path implementation, we have looked at some of that. Optimizations for BGP-SEC may enable the adoption of BGP-SEC, so that is another area. So those are multiple areas that one can explore.
Thanks for that answer, sir. So due to the constrained time, we are already exceeded 15 minutes more. So we would like to take one more last question. So the question is, the question is from Abhishek Adhikari. So what are the main cryptographic primitives that are used here?
Oh, okay. So it's the X.509, if you look up the details on that. So an extension of that is used for the RPKI, for the issuance of the resource certificates and the creation of the route origin authorizations. And on the other side, with the BGP-SEC path validation, it is again like the encryption. Basically the BGP encryption is encryption. The paths are signed, so each autonomous system gets a certificate of its own, and it uses the private key corresponding to the autonomous system of the resource holder. When they propagate a route in BGP, they are signing their updates with that private key corresponding to the resource certificate of their of their autonomous system. So those are some of the basic elements. If you look at RFC 8205, which is BGP-SEC, and RFC 8208, which is the algorithms, the encryption algorithms for BGP-SEC, you'll be able to get a lot more details.
Thank you so much for answering that. We are still getting some more questions, but I'm very sorry we are not able to take up at this right now due to this our constrained time. So it's time for us to thank you all. I would like to thank Dr. Olaf, in his very busy schedule, he took up time and to present us about cybersecurity stuff. Thank you so much, Dr. Olaf. And also it's time for us to thank our second speaker, Dr. Sriram. So I know it's very pleasant to hear from you about the routing stuff and much more on the security stuff and all. So we'd like to thank you for your precious time to present this stuff here. And also here I would like to thanks the Jolly, the one always help us for the live streaming. So thank you, Jolly, for your support. And also we have our SIG manager, Evelyn Manamara. So thank you so much for your continuous support of being with us for all these sessions. It may be an virtual or in physical sessions, what we will host. Always used to be with us. Thank you so much for that. And I would like to thank our collaborative partners here. So the first one partner is the Internet Society Cybersecurity Special Interest Group. Thank you so much for every officers there. And also we have, as I mentioned before, we have so many interest from the students on to hear about the cybersecurity. We have some collaborators in that one. So among that, we have collaboration from the to host this webinar is the IEEE Bangalore section. So is the partner and Anna Sahib Dangi College of Engineering and Technology, ASTE, and also our one more partner is Ramaya Institute of Technology, Bangalore. I would like to thank everyone to being part, and also thank you one and everyone so join this section, those who have joined in Skype and also in the live stream. Thank you everyone. So happy weekend and have a nice time. Take care.
Thank you, Adesh.